shout them out here and argue with each other. This first type of triangle, all three sides are equal. I call it a what?
Equilateral.
Here we go. Equilateral, everybody. EQU. That's an equilateral triangle. All right, equilateral. All good? What if I only have two sides congruent? Only two sides. The third side is not congruent to the rest. That is a?
Isosceles.
There we go. That's a spelling word, huh? Isosceles. Good. All right, well, three sides congruent, two sides. What if no sides are congruent? All three sides have different lengths. That's going to be called?
Scalene.
Scalene. All right, scalene. So that is how I can name a triangle if I know information about the sides. What if I don't know information about the sides, but I do know info on the angles? So I can also call a triangle based on its angle information. Now this first one I have up here, you'll notice my arc marks are on all three angles. So all three angles are congruent. I don't know, you could call it equilateral. All right, but another name if the angles are congruent, let this roll off your tongue right now, kids. Equiangular. How about that one? That gives you a chuckle once in a while. Equiangular. Nice, huh? Equiangular. Since we are in honors, let's raise the bar a little bit. If all three angles are equal and they add to 180, what is each angle measurement then in an equiangular triangle? What is all three angle measurements if they're all the same and they add to 180?
60.
60, 60, 60. Got it. Yep. Good job, kids. Again, you could refer to that as equilateral because if all three angles are equal, that means all three sides are equal. All right, you guys may have it on your, I don't know if you guys have it in your packet or not. Do you guys have an angle measurement already in your packet? Is there an angle measurement on this second triangle? Yes, no? What is it? So I could write it in myself.
Yeah. 105.
105, thank you. So this is a $1.05. All right, so if that's 105, anybody know what should I be calling this triangle now? You do not need the other angle measurements for this one. I just need to know that that one's 105, so I can call it
Obtuse.
Oh, there we go. There we go. Obtuse, yes. It's called obtuse because one of the angles is bigger than 90. All right, so if you have one angle bigger than 90 in a triangle, we call it obtuse. Doesn't matter the other two. As long as one's bigger than 90, it's automatically obtuse. Everyone good? All right, a couple more based on its angles. We should know this one right away. That's my right triangle. We've been dealing with those. And the last one, you guys probably have angle measurements in here too, I assume.
70 in the left, 30 in the right.
Thank you. All right, this type of triangle. You could find the other angle if you want, but it's not needed. This angle now would be?
Acute.
Acute. Got it. All right, so there we go. So I can name an angle based on its sides or based on its angle measurements. I'm sure you've heard of all these triangles, maybe not the equiangular, but most of them. All right, perfect. Let's actually work with some of these now. Example 1. M is the midpoint of JL. Got it? Got it. What type of triangle is JKM? Equilateral, isosceles, or scalene? All right, well, let's first start here. M is the midpoint of JL. We should be at the point in the year. You can give me a conclusion right now. If M is the midpoint of JL, give me two segments that should be equal to each other. Let's do this. We're starting with number 12 today. Number 12, Lucas, what can you tell me? If M is the midpoint of JL, give me two segments that are equal.
JM and ML.
JM is congruent to ML. Everybody agree? Everyone, look, they said that JL was 1.5 units long. JL was 1.5 units long. So what's got to be my measures for ML and JM now? What's the lengths, the actual lengths of JM and ML now? Okay, let's go to 20. Here we go. Radhika, what's each segment length?
1.5 divided by 2.
All right, good. Thank you. You want to let me know what that is?
0.75.
There we go. So 0.75 for JM and ML. Did you guys also see in the givens what was marked in our diagram? That KM was congruent to ML. Everyone see that in the givens? That was given to us. KM is congruent to ML. That was given. So what other two line segments have to be equal then? We had JM and ML by definition of a midpoint, and we have KM and ML. That was given. Name the other two segments that should be equal now. Here we go. Luke, what other two segments should be equal then? I got JM and ML, KM and ML.
ML and KM.
I got it already. That's given. That was given. Those are marked on the diagram. I got KM and ML. That was given. Which ones?
JM and KM.
JM and KM by substitution. Good. So does everyone see these segments that are all equal to each other? I got 0.75 here, 0.75 here, 0.75 here. All right. Let's answer the question. What type of triangle is J, K, M? All three sides are 0.75. What type of triangle am I working with? Here we go. Going to Gideon. What type of triangle?
Equilateral.
Equilateral. Why?
Because all sides are equal.
There we go. JKM is equilateral. Because all sides are congruent. Do I need all this work here that I showed you? No, but I kind of wanted to just go in a little bit of a proof format so you knew where all my values came from. Because we use definition of a midpoint, we use substitution here. Any questions on why that is an equilateral triangle? All right, moving on. I got an isosceles triangle now. What's the measure of each of the three sides? What's the measure of each of the three sides? Before you tell me the measure of each sides, I need an x value to plug in. I need to plug in for x. So I'm going to need somebody to come up with an equation for me that would solve for x. Need an equation that would solve for x here. Now be careful here. Think about it before you start spraying out an answer here to me. Okay, give me an equation where I can solve for x based on that it's isosceles, and I showed you what two sides were congruent. Okay, going here. Lucas, back to you. Got an equation for me that would solve for x.
No, I can't. I don't know how to do that.
Okay. I got two sides congruent up here. It's isosceles. Here we go. Let's try out. Sinjin got an equation for me.
4x plus 1 is equal to 5x minus 0.5.
4x plus 1 is equal to 5x minus 0.5. I could set those equal because they gave me the hash marks on there, so they're equal to each other. Here's where you guys get confused. You think that because they gave me 9x minus 1 that I got to use that too. No, you don't have to use all of them. And another common response I get is 9x minus 1 plus 5x minus 0.5 plus 4x plus 1 equals 180. Guys, what's the 180 for? That's for the angles add up to 180, not the sides. All right, so don't get in this mindset because I gave you all three side lengths that you have to use all three in the equation. That's not the case here. I only needed to set the two equal sides equal to each other, the two congruent sides equal. So go ahead, play around. I'll ask somebody for what you got for x here. Okay, what did we end up getting for x? Here we go. Going back. Radhika, here we go.
1.5.
1.5, everyone. Sound good? All right, take 1.5. Again, please watch out for this tomorrow on the test. This is not just find x and you're done. Reread the problem. Find each side. So I'm going to need somebody to tell me what AB is, AC, and BC. 3 different people right now to find those values. If you're not ready yet, take your time. Just tell me when you're ready. Here we go. 24. Emily, when you're ready, can I have the value of AB?
12.5.
Good work. 12.5. AC, the length of AC, everybody. 15. Here we go. Will, when you're ready, value of AC.
I got 7.
Yes, you did. Good job. 7. And finally, the value of BC. One above. Ellie, what's the value of BC?
7.
I hope so, right? Because they told me AC and BC were congruent, and it's isosceles. So 2 of my answers should have came out to be the same. Questions from you guys? Not too bad? Again, just because they give you the lengths of all 3 sides does not mean you need to use them in the equation. All right, only use the 2 you need. Moving on. Oh, a graphing one. Here we go. Yes. I'll give you a minute. Go ahead and graph triangle DEF. And then we're going to figure out a way to determine what type of triangle this is. So take a minute. Go ahead and graph it. I'm not too sure why we're on Go Formative right now. We should be on, thank you. We should be on what we're doing in today's notes. So yes, I am monitoring progress today. All right, everyone have it graphed. All right, we need to determine what type of triangle this is. Is it equilateral, is it isosceles, or scalene? Well, I can tell you, you're just not going to tell me, you know what? It looks isosceles, so I'm going to go with isosceles. Baloney. You're not going to do that. We need a way to determine what are the lengths of the sides. So I can tell you what type of triangle it is. So from Unit 1, there's your big hint for this problem. From Unit 1, do we have anything that will determine what the lengths of these sides are? Can you help me find the length of each side using something from Unit 1?
Pythagorean theorem. Something theorem.
We could use Pythag. Absolutely. So for instance, if I wanted to find the length of EF, I could turn this, take a look, into a right triangle. And then this, okay, yeah, that would be my C value, and A squared plus B squared equals C squared. Or, I just heard it, we could also get out the old distance formula from Unit 1, which I am going to do. So you could use Pythag. Go right ahead if you want to use Pythag. I'm going to use distance formula with you. x2 minus x1 all squared plus y2 minus y1 all squared. I will do one side with you, and then you guys are on your own for the other 2 sides. So I think I'm going to do FE. We're going to find the distance of FE right now together. Ready? All right, everyone take a look at coordinate E and coordinate F. The x values are -8 and 2. So -8 minus 2, all squared. The y values are 3 and 1. And I need to subtract those, all squared. Good so far. Any issues? All right, let's keep going. -8 minus 2, I get -10. I'd recommend you keep it in parentheses until you are done squaring. Plus 3 minus 1, 2 squared. All right, you guys could skip steps if you want. I'm just doing this step by step so you see where every number is coming from. I have 100 here. -10 is 100. Plus 4. So FE ends up being the square root of 104. Oh, and I know you hate when I ask this. What class are we in? Honors, right? So there is no shot you're going to be going to your calculator, doing the square root of 104 and giving me that sloppy long decimal. Absolutely not. You know how I want this. Simplest radical form. Break the radical down. How do I break down 104? You pick the biggest perfect square first. That goes into 104, the biggest perfect square. And just a reminder, if you don't know what the perfect squares are off the top of your head, you can go to y equals in your calculator, type in x squared on y1, type in x squared, and go to the table, second graph, the table, and under the y column are all the perfect squares. You're looking for the one, the biggest one out of all of these, that goes into 104 evenly. And you don't have to go that far because the biggest one ends up being 4. No other one goes into it evenly. And it's 4 times 26 gives you 104. 4 times 26. So finishing off this side length, square root of 4 is 2. That's where I'm getting that 2 from. Taking the square root of 4, and I bring down the square root of 26. All right, so there's FE. There's FE. Now let's say, before I let you go, let's say 104. There was no perfect square that went into 104. You're done. Okay, that's already in simplest form. If a perfect square does not go into your number, you are done. All right, so you got DE and DF left. DE and DF, go right ahead, and then we'll come back and talk as a group what we got. Let's get back to it. First one I'm going to look for is DE, everybody. DE. What did we get for the length of DE? Let's roll. Whew, here we go. Radhika, what do you got on fire today?
I got the square root of 113.
Yes, you did.
I'm not sure if that's downward.
You're fine. You're fine. Here again, guys, square root of DE. You should have got 8 squared and 7 squared, which gave you 64 and 49. And that gives you, add them together, you get square root of 113, and that cannot be broken down. That's it. There's no perfect squares that go into 113. So leave it. It's got to be a perfect square. You just can't find 2 random numbers that go into it. It's got to be a perfect square. Good job, Radhika. So a radical 113. And then how about DF here? DF. Going to the top. Vinny, what do we get?
I'm still working on it.
Okay, let me know when you're finished. Take your time.
I think I did something wrong. I just don't know what it is.
What number did you get underneath the radical?
45.
Okay, nothing's wrong. 6 squared plus 3 squared underneath the radical. You get 36 and 9, which is 45, but we can break that down. Ready, Vinny?
Oh, yeah.
What's a perfect square that goes into 45?
9.
9, yep. So 9 times
5.
5. Keep going here to finish this off. What's the square root of 9?
3 radical 5.
There you go, everybody. 3 radical 5 for DF. Good job. All right, look at the 3 side lengths now. 2 radical 26, radical 113, and 3 radical 5. What type of triangle am I working with here? What type of triangle is this one? 2. Quincy, what type of triangle do I have?
Could you repeat the question, please?
What type of triangle is this?
I forget the word, but no sides are equal, right? So,
Okay, look back in your notes if you have to, because we wrote it down at the beginning today.
is it scaling, or did I get confused? I'm not sure.
Triangle DEF. No sides equal is scalene. Isosceles is 2 sides, Quincy, and 3 sides is equilateral. We good?
Mhm.
Triangle DEF is scalene. And it does say explain because no sides are congruent. Everyone all right? The assignment for this notes, the assignment is due on Friday out of your textbook. Okay, the assignment is due out Friday. So you have a choice right now because we have 10 minutes left. You can start that assignment if you want, or you can go back to your Unit 3 packet and start doing some more review questions in preparation for tomorrow. I'm here too. So if you want to discuss a problem in your packet, a proof in your packet, or want me to make up a problem on a certain topic, I can do that in the next 10 minutes. It is your call, but you are staying on camera, signed in for me, please, until we are done with class. So you guys got a lot of options right now. All math options. We're not going to a different class right now. We're staying right here, starting the assignment that's due Friday, or going back to your packet and doing some more practice questions, or asking me questions if you have them. I know I'll be after school too, but if you guys just want to take this time to review anything with me, go right ahead.